this presentation, we are going to explain the criteria to select the anodes according with the material of the hull, according with the type of water, according with the type of propulsion system. But before I start that presentation, I want to refresh between aluminum, between zinc, and between magnesium, which one is more anodic? Magnesium. It's more anodic. After that, I think that the aluminum alloy and the last one is zinc.
Yeah. Magnesium is negative 1.6, aluminum is negative 1.1, and then zinc is negative 1.05.
1.05. Okay. What is the meaning that is more anodic?
More negative.
It's propense to be eroded faster because it's more anodic, no? You know, magnesium will be eroded faster because it's more anodic. We are going to check what is the level of electronegativity, or no, what is the potential difference produced for the aluminum alloy, the zinc alloy, and the magnesium alloy. Also, I want to refresh one topic that I explained at the beginning of this course. Those anodes in aluminum, in magnesium, in zinc, it's not pure aluminum, it's not pure zinc, it's not pure magnesium. Those are special alloys with the main component magnesium, the main component zinc, and the main component aluminum. For example, this one, zinc. Zinc is the military alloy based on aluminum, and is the number is 18001K. This is the name of that alloy. It's a military alloy. That alloy was discovered for the metallurgical engines, the military metallurgical engines. All right. For example, aluminum. Aluminum. This is the name. The technical name is a MIL A24779SH. That's the specification of that alloy. It's not pure aluminum. Oh, the main component is aluminum. That's correct. But aluminum plus other ingredients. And that alloy is highly anodic. For example, magnesium. This is the technical name of that alloy. That's okay? And now we are going to check the voltage reference of those alloys. We are going to check the electrical potential of magnesium. It's minus 1.6. Negative 1.6. It's highly anodic. What about zinc? Minus 1.05 versus minus 1.6. Magnesium is more anodic, no? What about aluminum? Minus 1.1. Okay. In terms of anodic, more anodic magnesium alloy. After that, the aluminum alloy, and the last one is zinc. And the most famous is zinc, no? Okay, now we are going to check those alloys according with the type of water. If it's salt water, if it's fresh water, or if it's brackish water. What is the meaning of brackish water?
Mixture.
Yeah. All right. Where I found that brackish water, normally. The canals, no? Yeah. Okay. We are going to analyze. We are going to start with zinc. Zinc in fresh water. What happened with zinc in fresh water? It's a poor protection in fresh water. Anodes of zinc in a boat in fresh water, that protection is poor. Okay, nice. Let me check what happened with zinc in salt water. Zinc in salt water is recommended. It's full recommended. Nice. Okay, let me check magnesium. Magnesium in fresh water. Recommended. Magnesium alloys in fresh water, fully recommended. What about magnesium in salt water? Not recommended in salt water because produce overprotection, because it's highly anodic with a with salt water, excellent conductor of electricity, produce overprotection. Okay, let me check aluminum. Aluminum with fresh water. The protection of aluminum in fresh water is fair. It's not bad, but so-so. Okay, what about aluminum alloys anodes in salt water? Recommended. Recommended. Aluminum is good, no? Recommended in salt water, in brackish water. Oh, okay, so-so. It's not bad. This is in terms of water. And now in terms of excuse me, and brackish water. What happened aluminum in brackish water? In brackish water, aluminum alloys are recommended. Good. Let me refresh brackish water for zinc. Brackish water, fair protection. So-so. What about brackish water for magnesium alloys? Not recommended. Overprotection. Okay, interesting, no? That analysis with respect to the water. And now we are going to check the same analysis, for example, for inboard and outboard. What happened with the anodes of zinc with inboards? Okay, that depends. Depends if the boat is in wood, if the boat is in aluminum, if the boat is in fiberglass, and if the boat is in steel. We are going to start with a fiberglass hull. What happened in a fiberglass hull? Okay, the anodes of zinc are recommended in salt water with fiberglass hull. Good. The anodes of zinc are recommended in brackish water with fiberglass. Okay, great. Let me check what happened if the hull is in wood. The anodes of zinc are recommended in salt water with wooden boats, with wooden hull. And the anode of zinc are recommended in brackish water with wooden hull. And also, the fastener recommended in wooden boats is silicon bronze. Oh, silicon bronze are those alloys 655, 954, naval bronze, and tubing bronze. Those are considered silicon bronze alloys. Good, guys? Okay. Let me check what happened if my boat is on a inboard boat, inboard engines with aluminum hull. The anodes of zinc recommended in salt water with aluminum hull. The anodes of zinc not recommended in fresh water with aluminum hull. And the anode of zinc recommended in brackish water with aluminum hull. Oh, my friend, this presentation is epic, believe me. And what about the fastener? Stainless steel. In that particular case, anode of zinc with aluminum hull, the fastener recommended is stainless steel. Stainless steel, all of those series, 304, 316, 18A, 1810, aqualoy, and aqualoy. Nice. Let me check, guys, for example, I was talking about zinc. Now we are going to talk about magnesium. Magnesium, and what happened with the magnesium in inboards? In inboard, depend on the hull, once again. Okay, what about if the hull is in aluminum? Magnesium, recommended in fresh water with aluminum hulls. Recommended with the aluminum hull in salt water. Not recommended aluminum hull in brackish water. And the fastener, stainless steel. Marine grade stainless steel. You like it? The presentation, guys?